Let's take a look at how you can program an ultrasonic sensor. So I'm assuming that you already have this wired with the 4 pins from the diagram. And so the first thing we're going to do is go make some variables. So I'm going to say int echo pin. Now this will match whatever pin you put it into. Just make sure it's a digital pin. So I'm putting mine into 8. And then I'm going to need my trig pin. So trig pin, and I wired this one into 9. There's a couple other variables we need here along the way. So one of them is how long it actually takes for the Arduino to send the signal out and for it to return back to it. So that's going to be a double. So we're looking for a decimal. I'm going to call that return time. And for now, I'm going to set that to 0 just as a placeholder. And the second thing, which is the thing we actually want, is, well, how far is something for my ultrasonic sensor? So I'm going to call that an int distance. And again, I'll set that to 0 to start. Now that I have all my variables set up, I can go into my setup and actually tell what each pin is going to do. So first of all, we're going to look at the trig pin. So pin mode, and that's my trig pin. And it's going to be sending out electricity, so it's going to be an output. Next, we're going to look at the echo pin. So echo pin, and that's the one that's going to be listening for electricity, kind of like a button. It's a little more complicated than that, but it does all the work for us. And finally, I'm going to set up my serial monitor so that I can actually make sure that it's working. So serial.begin, and I'm going to use 9600. From here, we're all ready to go. We can go into the loop and actually try to read out some information. First, we're going to make sure that there's no other waves being sent out, no other pulses. So I'm going to call this clearing the trig pin. And what I mean by that is I'm going to make sure that the trig pin has been turned off for at least 2 microseconds. So a very short amount of time. So digital write, and we'll say trig pin has been turned to low. And then I'll put my delay. So just a normal delay is in milliseconds, but we want in microseconds, so even smaller. So microseconds, and I'm just going to put 2, just enough time to say, hey, we know for sure it's been off for some amount of time. Now after that, we want to actually send out the signal from the trig pin. So it's going to send out an ultrasonic wave, and we want that for 10 microseconds. So extremely short amount of time. I'll just write a note here, send signal for 10 microseconds. If I can spell. So I'm going to do a digital write on that trig pin, and it's going to be high. We're going to do a delay to make sure it stays on. So delay microseconds, and that's going to be for 10 microseconds. And then we're going to turn it off. So now we've got this signal that's in the abyss. So at this point then, we're actually trying to listen for the echo. So I'm going to put here, listen for echo. Now we're not going to go super in depth into what's happening here or how it's taking in information. We're going to let the Arduino do the work. So I'm calling this my return time, and it's equal to a pulse in. Now this is sort of like a digital read, but a digital read is just, hey, electricity's on, it's off. This is looking for an on, off kind of wave deal. So we're looking for the echo pin, and we're going to set that to high. At this point, I want to just see, is it working? Is it doing anything? So we're going to go serial.print line, and I'm just going to print out what does that return time look like. And so I'm going to upload this, look at my serial monitor, and we're getting some numbers here, some very large numbers. And if I put my hand very close to the ultrasonic, the numbers get smaller. And if I put them farther away, they get very, very big. So this is the amount of time that it's taking for the sound wave to come out of the Arduino, hit my hand, and go back. But I don't want time. I want distance. So I need to go and actually do that calculation. So let's call this distance calc. Now the calculation for distance is distance equals speed times time. And this makes sense. Like if I'm driving on the highway to Calgary at 100 kilometers an hour for 3 hours, that's 3 times 100. Yeah, I've gone 300 kilometers per hour. So same deal here. We know the time really well because we just did that. So our only thing we have to figure out is our speed. Now in our case, we're looking at the speed of sound. So that's 344 meters per second. So extremely fast. I don't want this in meters. I want it in centimeters. So we are going to do some calculations or conversions anyway. I'm just going to give it to you. So its distance is equal to our speed, which in this case is 0.034. Now this is in centimeters per microsecond. Okay, so very, very small. And I'm going to multiply that by my return time. So this is the exact same calculation I was talking about if I'm driving to Calgary. Instead of 100 kilometers per hour, this is my speed in centimeters per microsecond. And then how much time I actually drove, or how much time it took for it to go from the Arduino, hit my hand, and come back. So at this moment, I'm going to go and write this in the serial monitor. So serial.print line. And I'm just going to write out distance. And then I'm going to concatenate it. Now we will have to make it into a string now. So I'm going to say distance. And there we go. So let's see if this works. All right, so I'm going to put my hand extremely close, like 5 centimeters away, and I'm getting 10, 8, and now I'm about 30 centimeters away, and I'm getting 60. So it's like double what I'm saying. You can see what it's flickering here on and off. And the problem right now is the return time is too big. It's the time from the Arduino to my hand and back. So it's actually exactly double the amount of time. So to fix that, we're going to divide by 2. So now it's only a one-way trip on there. So if we re-upload this, and I'll put my hand about 5 centimeters away, and hopefully, 3, 4, sure. I said it was approximately about 30 centimeters away. Yep, that looks pretty good. Now, do be aware if you get too close to the ultrasonic, it will just start failing. It has no clue because it has nowhere for the sound to actually come out. At this point, you can use this information for whatever you want. So you can do something like if distance is greater than 30, and again, that's in centimeters. Hey, we could turn on LED, and could be a sound, could be whatever you want it to be. And then otherwise, we're going to turn off LED. So you can use this information from the distance sensor however you want in your program.